Good morning, everybody. We're back again to talk about steel. Today we're going to talk about pH stainless steels. Well, what are pH stainless steels? Great question. Now in this video we're just going to touch on the basics. Stay tuned. In future videos we will delve deeper into more detail. If you have learned anything, if you've been enjoying these videos, if you want to see more, or if this is just your first time and you really do like it, please consider hitting the little button that says MMI right here. Just consider clicking that little subscribe button. That would be helpful. If you like this video, how about a thumbs up? Like it. Give me a little comment. Ask me a question. I'd be happy to try to help. Now, back to some pH stainless steels. What does the pH even stand for? Well, pH stands for precipitation hardening, which is a heat treatment that is just a bit different from the conventional heat treatment of the Martensitic types that we've discussed in the previous two videos. An initial solution treatment at high temperature, typically 1900 degrees Fahrenheit, assures that all the alloy elements needed for the hardening reaction are uniformly distributed within the metal structure. At these temperatures, the structure is austenitic. From this temperature, the alloy is cooled at a rate that retains the distribution of the hardening elements in solution. High strength, excellent corrosion performance, and a simplified heat treatment process are advantages of the pH types as compared to the conventional Martensitic types. Depending on the chemical composition of the specific alloy, the resulting structure after the solution treatment is either Martensitic, semi-austenitic, or austenitic. These structures contain more of the hardening elements than would be completely stable, so it's just waiting for an additional heat treatment to cause things to happen within the structure. But things are stable enough that we can choose to fabricate components prior to the final hardening heat treatment. This additional, relatively low temperature heat treatment is called aging. The increased temperature and time allows the element's mobility to combine and form the precipitates, which are particles that then strengthen the structure. Well, they're like particles. Before we go, let's split the pH alloy types by the solution-treated structure. First up is the Martensitic types. They form a low-carbon martensite, relatively soft but also brittle, when solution-treated. Alloy should not be used in the solution-treated condition. When reheated to the aging temperatures, the particles that form further strengthen the structure and improve toughness and corrosion performance. The resulting heat-treated condition is designated by the letter H followed by the aging temperature. For example, H900 indicates that it has been solution-treated and then aged at 900 degrees Fahrenheit. Hardness increases and yield strength minimums of 170,000 psi are achieved with this second simple heat treatment. Conditions range from H900 through H1150 and even a double H1150 with two aging sessions at 1150 degrees Fahrenheit. The higher the aging temperature, the lower the strength, but toughness is increased. H1150M is an overage condition producing the lowest hardness. Solution treated, solution annealed, and condition A are synonyms in describing condition. Often these types are solution treated by the producing steel mill, and then the aging treatment is performed after additional fabrication to parts. If already in the required aged condition, then no further heat treatment is required. It's all a matter of what provides the best manufacturing plan. Common grades in this group include 17.4, aka 630, 13.8, 15.5, 450, and 455. 15.5 and 13.8 are examples of premium vacuum melted grades. The additional melting under vacuum minimizes any harmful impurities for critical applications, like highly stressed aerospace components. Grades can also have multiple vacuum melting that we will touch on in the next video. Corrosion performance and suitability for application is best left to the professionals to specify the alloy and condition required. Check the spec. Remember, always check the spec. Be on the lookout for any specifications always. The devil is in the details, and sometimes he's hiding. So, you want to learn more? Stay tuned for part 2. Those are going to be the austenitic and semi-austenitic types. Don't forget to subscribe. Okay, click here. And if you can, you need more information, previous videos, click here. This is Michael with Michelin Metals.